Our next example is the function f from reals into reals defined by f of x equals e to the x. And we all know what e is. It's that irrational number, the constant 2.7 something or other. Well, let's test this out. If f of x is equal to f of w, then what that means is e to the x equals e to the w. E is a positive number, so if e to the x equals e to the w, that means that x is equal to w. Therefore, injective. I just wrote 1 to 1. So yes, it is an injective function. Now let's check to see if it's surjective. Well, notice e to the x is always a positive number. So does that tell you right now whether this is surjective or not? Of course, it's not surjective. For example, f of negative 1 equals e to the x has no solution. So that means that no value of x, right here, will ever give you a negative 1, or actually any negative number at all. So f is not surjective. Again, I'm using the different words and different terms just to get you used to them. Surjective is onto. It's not onto. But notice this. The function, I'm going to use a different letter. Oops. If I choose G mapping all the real line into the positive numbers, this is every positive number, and it does not include 0. Defined as g of x equals e to the x is onto or surjective. So by changing the image, the range, the codomain to 0 to infinity, just the positive numbers, we could turn it into a surjective function. And if you remember real quickly what the graph looks like of e to the x, something like this. And you can see pretty easily that the heights this function takes on can get as close to 0 as you want to as you go to the left, anything positive, and then it goes all the way up to infinity. So because this, we change it to this, 0 to infinity, now we have an onto or surjective function.